Welcome to our journey through the Asteroid Belt, a fascinating region of our solar system that lies between Mars and Jupiter. This mysterious belt is home to millions of rocky bodies, ranging from tiny pebbles to dwarf planets. For centuries, astronomers have been captivated by its secrets, wondering how it formed and what stories it holds about the early days of our solar system. Today we'll explore its origins, composition, and the role it plays in the cosmic dance of planets. Let's begin our adventure by understanding where exactly the asteroid belt is located and why it's so important to scientists and space enthusiasts alike. Asteroid belt is a vast region situated between the orbits of Mars and Jupiter. If you imagine our solar system as a series of concentric circles, the belt forms a ring that separates the inner rocky planets from the outer gas giants. This unique position has made it a subject of intense study, as it acts as a kind of boundary zone. The gravitational influence of Jupiter plays a significant role in shaping the belt, preventing the material within it from coalescing into a planet. Understanding its location helps us appreciate its significance in the broader structure of the solar system. The discovery of the asteroid belt dates back to the early 19th century. Astronomers noticed a gap between Mars and Jupiter and theorized that a planet should exist there. Instead, they found a collection of small objects, starting with Ceres in 1801. This discovery was soon followed by the identification of other large asteroids like Pallas, Juno, and Vesta. The realization that this region was filled with countless rocky bodies rather than a single planet changed our understanding of planetary formation and the dynamic processes at play in our solar system. Asteroids are rocky remnants left over from the early formation of our solar system. They vary greatly in size, from tiny dust particles to objects hundreds of kilometers across. Most asteroids are irregularly shaped, lacking the gravity to pull themselves into a sphere. Their surfaces are often covered in craters from countless collisions over billions of years. By studying asteroids, scientists gain valuable insights into the building blocks that formed the planets and the conditions that existed in the solar system's youth. Ceres is the largest object in the asteroid belt and holds the distinction of being classified as both an asteroid and a dwarf planet. With a diameter of about 940 kilometers, Ceres makes up nearly a third of the belt's total mass. Its surface is a mix of rock and ice, and recent missions have even detected signs of water vapor, hinting at possible subsurface activity. Ceres is a prime target for scientific study, as it may hold clues to the presence of water elsewhere in the solar system. Besides Ceres, the asteroid belt is home to several other large and significant bodies. Pallas, Vesta, and Hygiea are among the largest, each with unique characteristics. Vesta, for example, has a massive crater at its south pole, evidence of a colossal impact in its past. These large asteroids are like miniature worlds, each with its own story to tell. Studying their surfaces and compositions helps scientists piece together the history of the belt and the solar system. Asteroids in the belt are composed of a variety of materials. Some are made mostly of rock, while others contain significant amounts of metal or even ice. Scientists classify asteroids into different types based on their composition: C-type carbonaceous, S-type silicaceous, and M-type metallic. This diversity reflects the different conditions that existed in the early solar system and provides a window into the processes that shaped our planetary neighborhood. C-type or carbonaceous asteroids are the most common in the asteroid belt, making up about 75% of known asteroids. These bodies are rich in carbon and often appear very dark. Their composition is thought to be similar to the primordial material that formed the solar system. By studying C-type asteroids, scientists hope to learn more about the organic compounds that may have played a role in the origin of life on Earth. S-type or silicaceous asteroids are the second most common group in the belt. These asteroids are made primarily of silicate minerals and nickel iron. They tend to be brighter than C-types and are often found in the inner regions of the belt. S-type asteroids provide important clues about the differentiation of planetary bodies and the distribution of materials in the early solar system. M-type or metallic asteroids are less common but extremely interesting. These bodies are composed mostly of nickel and iron, and some may be the exposed cores of ancient protoplanets that were shattered by collisions. M-type asteroids are valuable for understanding the metallic content of the solar system and may even become targets for future mining missions due to their rich metal resources. The asteroid belt isn't a dense, packed region as often depicted in movies. Instead, it's a vast area with large distances between individual asteroids. If you travel through the belt, you likely see more empty space than rocks. The belt's structure is shaped by the gravitational pull of Jupiter, which creates gaps known as Kirkwood gaps. These gaps correspond to orbital resonances where Jupiter's gravity has cleared out material. Kirkwood gaps are regions within the asteroid belt where very few asteroids are found. These gaps occur at specific distances from the Sun, where an asteroid's orbital period would be a simple fraction of Jupiter's. The repeated gravitational tugs from Jupiter at these locations cause asteroids to be ejected or moved to different orbits, creating the gaps we observe today. Within the belt, some asteroids form groups called families. These families are collections of asteroids that share similar orbits and are believed to be fragments of larger bodies that broke apart in collisions. By studying asteroid families, scientists can reconstruct the history of catastrophic impacts and the evolution of the belt over time. The asteroid belt is thought to be made of material that never formed into a planet. Early in the solar system's history, gravity from Jupiter prevented these building blocks from coming together. Instead, they remained as smaller bodies, colliding and fragmenting over billions of years. This ongoing process has shaped the belt into what we see today, a dynamic, ever-changing region filled with relics from the solar system's birth. Jupiter's immense gravity has had a profound impact on the asteroid belt. Not only did it prevent the formation of a planet in this region, but it continues to influence the orbits of asteroids today. Jupiter's gravitational pull can send asteroids hurtling into new paths, sometimes even ejecting them from the belt entirely. This ongoing interaction is a key reason why the belt remains a collection of small bodies rather than a single large planet. Collisions are a common occurrence in the asteroid belt. Over billions of years, asteroids have smashed into each other, breaking apart and creating smaller fragments. These collisions are responsible for the formation of asteroid families and the craters seen on many asteroid surfaces. Studying these impacts helps scientists understand the processes that shape not only the belt, but also the surfaces of planets and moons throughout the solar system. Some asteroids are knocked out of the belt and sent on trajectories that cross Earth's orbit. When these fragments enter our atmosphere and survive the journey to the ground, they become meteorites. By analyzing meteorites, scientists can study material that is billions of years old, offering a direct link to the early solar system and the processes that formed the planets. Humans have sent several spacecraft to study the asteroid belt up close. Missions like NASA's Dawn Spacecraft have visited Vesta and Ceres, providing detailed images and data about their surfaces and compositions. These missions have revolutionized our understanding of the belt, revealing complex geology, evidence of water, and signs of past activity. Each new mission brings us closer to unraveling the mysteries of this distant region. Dawn Spacecraft was a groundbreaking mission that orbited both Vesta and Ceres. It provided high-resolution images, mapped surface features, and analyzed the chemical makeup of these bodies. Dawn's discoveries included evidence of ancient water flows, bright spots on Ceres thought to be salt deposits, and insights into the internal structures of these asteroids. The mission demonstrated the value of robotic exploration in expanding our knowledge of the solar system. In addition to Dawn, other spacecraft have flown by or studied asteroids in the belt. The NEAR Shoemaker mission landed on Eros, while Japan's Hayabusa missions have returned samples from near-Earth asteroids. Each mission adds to our understanding of asteroid diversity and the processes that shape these ancient bodies. Future missions are planned to explore more asteroids and even return additional samples to Earth. One of the most exciting discoveries in recent years is the presence of water on some asteroids, especially Ceres. Water exists as ice beneath the surface and may occasionally erupt as vapor. The presence of water has important implications for the possibility of life and the future of space exploration, as water can be used for drinking, growing food, and even making rocket fuel. Some asteroids contain organic compounds, molecules based on carbon that are essential for life. The discovery of these compounds on asteroids supports the idea that the building blocks of life may have been delivered to Earth by impacts in the distant past. Studying these materials helps scientists explore the origins of life and the distribution of organic matter throughout the solar system. Asteroids are rich in valuable resources, including metals like iron, nickel, and even precious metals such as platinum. The idea of mining asteroids has captured the imagination of scientists and entrepreneurs alike. In the future, asteroid mining could provide materials for building in space, supporting long-term missions, and even supplying resources back to Earth. While still in the early stages, this concept could revolutionize space exploration and industry. While most asteroids remain safely in the belt, some are nudged onto paths that cross Earth's orbit. These near-Earth asteroids can pose a threat if they collide with our planet. Scientists closely monitor these objects, tracking their orbits and developing strategies to deflect any that might be on a collision course. Understanding the dynamics of the belt is crucial for planetary defense. Efforts to protect Earth from asteroid impacts include tracking programs, early warning systems, and even proposed missions to deflect dangerous asteroids. By studying the asteroid belt and its dynamics, scientists can better predict potential threats and develop effective responses. International cooperation is key to ensuring our planet's safety from these cosmic hazards. Asteroids have captured the public's imagination, appearing in countless movies, books, and video games. From thrilling tales of asteroid impacts to daring space missions, these rocky bodies are a staple of science fiction. While Hollywood often exaggerates the dangers, the real science behind asteroids is just as fascinating, offering endless opportunities for discovery and adventure. Some scientists believe that asteroids may have played a crucial role in the origin of life on Earth. By delivering water and organic compounds through impacts, they could have provided the essential ingredients for life to begin. This theory is supported by the discovery of amino acids and other organic molecules in meteorites. The study of asteroids continues to shed light on this intriguing possibility. The asteroid belt is a natural laboratory for planetary scientists. By studying its composition, structure, and dynamics, researchers gain insights into the processes that shape not only the belt, but also the planets and moons of our solar system. The belt's diversity makes it an ideal place to test theories about planetary formation and evolution. The asteroid belt has played a significant role in the evolution of the solar system. Its material has bombarded planets and moons, shaping their surfaces and influencing their development. The belt also acts as a reservoir of primitive material, preserving clues about the conditions that existed when the solar system was young. The asteroid belt presents both challenges and opportunities for space missions. Navigating through the belt requires careful planning, but the vast distances between asteroids make collisions unlikely. Missions to the belt have provided invaluable data, and future missions may use the belt as a stepping stone for exploring the outer solar system. Space agencies around the world are planning new missions to study the asteroid belt. These missions aim to map more asteroids, return samples to Earth, and test new technologies for deep space exploration. As our knowledge grows, so does our ability to unlock the secrets of this ancient region and its role in the solar system. In the future, humans may visit the asteroid belt as part of our expansion into the solar system. Asteroids could provide resources for building habitats, fuel for spacecraft, and even serve as waypoints for missions to Mars and beyond. The challenges are great, but the potential rewards make the belt an exciting frontier for exploration. Despite decades of study, the asteroid belt still holds many mysteries. Questions remain about its exact origins, the processes that shaped its current structure, and the potential for hidden worlds within its vast expanse. Ongoing research and exploration promise to reveal new surprises and deepen our understanding of this enigmatic region. Studying the asteroid belt helps scientists understand similar belts in other planetary systems. Observations of distant stars have revealed debris disks that may be analogous to our own belt. By comparing these systems, researchers can learn about the formation and evolution of planets throughout the galaxy. The asteroid belt is affected by space weather, including solar radiation and cosmic rays. These forces can alter the surfaces of asteroids, causing them to darken or change over time. Understanding how space weather interacts with asteroids helps scientists interpret observations and plan future missions. The asteroid belt preserves a record of the solar system's history. Its rocks have remained largely unchanged for billions of years, offering a glimpse into the conditions that existed when the planets were forming. By studying the belt, scientists can reconstruct the timeline of events that shaped our cosmic neighborhood. Exploring the asteroid belt has driven advances in technology, from spacecraft propulsion to remote sensing instruments. Each mission pushes the boundaries of what's possible, inspiring new innovations that benefit not only space science but also life on Earth. The challenges of exploring the belt continue to fuel technological progress. Asteroid belt is a popular topic in science education, sparking curiosity and inspiring students to learn more about space. Educational programs and resources use the belt to teach concepts in astronomy, physics, and planetary science. By engaging with the mysteries of the belt, learners of all ages can develop a deeper appreciation for our place in the universe. Artists have long been inspired by the beauty and mystery of the asteroid belt. Paintings, sculptures, and digital art capture the imagination, depicting the belt's vastness and the drama of its rocky inhabitants. Art helps bring the wonders of the belt to a wider audience, blending science and creativity in powerful ways. Looking ahead, the asteroid belt will continue to be a focus of scientific research and exploration. As technology advances, we'll be able to study more asteroids in greater detail, uncovering new secrets and perhaps even finding resources to support humanity's expansion into space. The belt's story is far from over, and its next chapters promise to be just as exciting as its past. Exploring the asteroid belt is a global effort, with scientists and space agencies from around the world working together. International missions, data sharing, and joint research projects help accelerate discoveries and ensure that knowledge is shared for the benefit of all. Collaboration is key to unlocking the belt's mysteries and advancing our understanding of the solar system. Public interest in the asteroid belt is higher than ever, thanks to exciting discoveries and dramatic space missions. Outreach programs, documentaries, and citizen science projects invite people of all ages to participate in the adventure. By engaging the public, scientists can inspire the next generation of explorers and foster a deeper connection to the cosmos. The search for life beyond Earth includes the asteroid belt. While the belt itself may not host life, its water and organic compounds could be crucial for life elsewhere. By studying these materials, scientists hope to understand the potential for life in other parts of the solar system and beyond. As humanity looks to the stars, the asteroid belt stands as both a challenge and an opportunity. Its resources, mysteries, and strategic location make it a key destination for future explorers. Whether for science, industry, or adventure, the belt will play a vital role in our journey beyond Earth. Asteroid belt remains one of the most intriguing regions of our solar system. Its rocky inhabitants, ancient origins, and untapped potential continue to captivate scientists and dreamers alike. As we continue to explore and learn, the belt will undoubtedly reveal new secrets, deepening our understanding of the cosmos and our place within it. Thank you for joining us on this journey through the asteroid belt.